take over for the moderation of the final exec panel. Shravan, floor is yours.
Thanks, Michael. So welcome everyone. I think I already see Holger and Jochen. Oh, Liu is also here. So welcome everyone for this panel discussion. I think we have really a nice outlook regarding the TOPCon technology. Jolywood speaking on production side, so the real producer, and Jochen gave some research insights, how to improve, or what could be. Gave quite a nice overview about the importance of wet chemical benches, not only specific for TOPCon but also for other high efficiency, and also the current state of the art, which is PERC. So, but however, I think our panel discussion, I would like to rather limit to the TOPCon, but of course, sometimes we might have to jump onto the other topics. So what I want to cover today is really, I have 5 topics. One is contemporary technologies, and I would also like to discuss a little bit about the commercialization, manufacturing efficiency, application, then reliability, and what's coming, what would be the next generation technologies for TOPCon. So, starting, more than a Q&A session, I think it would be nice if we can discuss really, the topics. So, just to start with, I just want to start with the contemporary technology. So, it may not be appropriate to compare TOPCon with the heterojunction, but since both are N-type technologies, and there are also 2 main options for people who want to go beyond PERC. So, can you just, in your own views, so what are the important advantages of TOPCon over heterojunction? And this is also a question. So why it seems that TOPCon is kind of losing against heterojunction? But of course, you can also contradict me if you don't think it's losing. So Liu, do you want to start? Oh, you were on mute. Please unmute yourself.
Hi. Yeah.
Yeah.
It's okay.
Yeah.
Okay. In the future development, I think TOPCon. I prefer N-type TOPCon technology. Firstly, according to the current water efficiency record, the cell efficiency of TOPCon now is 25.7%, and the heterojunction solar cell is about 25.1. So in the lab, the cell efficiency of TOPCon is higher than the heterojunction solar cell. The second one is the theoretical calculation have showed that the TOPCon solar cell limited efficiency is about 28.7%, and the heterojunction solar cell is about 27.5%. And this is not important in mass production line. Now, for the TOPCon solar cells, the mass production efficiency is about 24%, and for heterojunction solar cell is also about 24%. But the cost of TOPCon is much lower than heterojunction solar cells. Now, Jolywood have about 2 gigawatt TOPCon solar capacity. The cost is just 1 cent higher than the PERC, and for the heterojunction solar cell, the cost I hear about 2 times higher than PERC. So the efficiency of TOPCon and the heterojunction is almost the same in the mass production, but the cost of TOPCon is much lower than heterojunction solar cells. And what's important is that the equipment compatibility. For the TOPCon solar cells, we can upgrade the PERC lines to TOPCon lines by adding LPCVD and the pulpit and some cleaning process equipment and so on. But for the PERC lines, it's totally very difficult to upgrade to the heterojunction solar cells, solar cell lines. So I think in future, TOPCon solar cells may be by adding capacity by upgrade PERC lines and some new fab we can use the new TOPCon equipment and because the high efficiency and the lower cost and it's competitive in the LCOE. Okay.
So I still have one more question, but I think I will come back to you again with that. But you know, any other comments from Holger?
I can only emphasize maybe the last point, Dr. Liu mentioned. So in principle, of course, TOPCon is for the current mainstream technology, which is, I think, Holger showed that numbers, 150 gigawatt production capacity outside. On PERC, it is really, let's say, representing the relatively logic evolutionary way of upgrading. And that's, of course, as was mentioned, it would be difficult to upgrade from PERC to heterojunction. In principle, heterojunction would mean it's a completely different path. Of course, on a high efficiency, and if you consider, for example, setting up complete new lines, so then you always would have the decision which you choose. But as an upgrade option, like it was earlier from aluminum BSF to PERC, TOPCon definitely I think is then the best choice. And maybe one aspect I want to mention is in the moment you see, let's say, this enormous size increase, of course, in the PERC technology, and this is, of course, something where currently you do not see for heterojunction. So it seems, of course, that it is definitely much more difficult for heterojunction to have the same size adaptation. So most of the manufacturers still remain at M2. Maybe they go to M6. At least some of them, like Ginergy, already achieved that. Others might start that now. But the PERC world is already at M12. For TOPCon, in principle, that should be also feasible. So maybe all the evolutions which are now going on in the PERC field in terms of wafer sizes might be relatively similar then also in TOPCon, and might be more difficult for heterojunction. Holger?
Holger, please.
Okay, I think I can exactly agree on what Jochen said before. It is important to realize that we've done within the last year these huge steps in larger wafer sizes, and throughput is going incredibly high at the moment for PERC tools, wet chemical tools. This is a huge boost again. If I look on the technology flows, the equipments, the automation, the handlings, it can be easily adopted on TOPCon. As I try to emphasize, I think we've seen a rollout of TOPCon, people hesitating because they were not such as experienced as Jolywood at the moment. They run this quite long time, but yield, I remember Leo was a long time a real big challenge. They're coming record sales out, but if the yield does not really fit at the moment, if the process flows are not optimized, and metallization. So two-side silver metallization is really something I see as challenging. And but I guess that paste manufacturers started to adapt, things getting better. And this is really, yeah, people right now believe, okay, do we stay close to something like PERC going to TOPCon? or should we make the large step? From the wet chemical point of view, the heterojunction for us is really a sophisticated wet chemical processes to close to what we do in semiconductor. Seeing that texturing is right now in cost-wise and in reflectivity getting better in PERC again, but cannot be applied to heterojunction, which is so sensitive as we not have a thermal process afterwards anymore. Passivation goes directly on the etching surface we leave. So I would say it's another shift in time before we see a new technology like heterojunction. Parts might go earlier the way than in the way of TOPCon.
Okay, but you partly answered the question, but if you compare with heterojunction, most of the expansion plans, if you really follow the expansion plans of the big companies, heterojunction is almost in every headline. So there is some bits and pieces of the massive expansion plans are reserved to heterojunction. On top of that, there are big plans. But of course, one can argue how much of this would really come into the reality. No one knows, but things are moving much faster compared to TOPCon, because TOPCon was also in the news, but then there was a kind of, it's a bit slow now. It's cold, I would say. And then, well, if you think metallization could be one of the issues, but heterojunction also has silver on both sides, and it's even more expensive, So
this is, let me answer this. Yeah, I think we will for sure. I can mention to Michael the order book saying there's more heterojunction ongoing, and the people will challenge it in mass production with new players of tools. Checking if they can do larger wafers, checking if they can do higher throughputs, and these things will for sure be installed. But the story with the cost then will be put on a production level more, and we will see it more over. The story is just, okay, you can go even higher in efficiency. And the risk is a completely new process and a very sensitive handling. So we will see the heterojunction installations for sure, but I also believe in a move in a TOPCon. So quite similar.
Okay.
And
I Dr. Holger.
Also
okay. Yes, for the last 2 years, for the N-type solar cells, the yield rate is a challenge. Now, we are achieved our yield rate is about 25% in our mass production line. For our second generation TOPCon technology, and the process is just 9 steps, the yield rate now is have reached 97%, and in future, I think the yield rate may be exceed 98% and even high. So for the TOPCon solar cell in future, I think it is the most competitive. This is why in the Middle East, our product can guarantee our customer get the lowest LCOE in the Middle East market. Thank you.
Jochen, you were about to say something.
Yeah. So I mean, it was just also one comment on, let's say, the heterojunction, let's say, expansion, which is at least announced. Yeah. I mean, until now, of course, I think it was also in I think even in your now recent report. Of course, I mean, 2021, it will be, I mean, we will see how really this is coming up. I mean, because up to now, of course, and if you look at the N-type figures from Longi, what they are selling, for example, I mean, it is still a relatively small capacity outside for heterojunction. Of course, announcements are large, but announcements are, of course, also enormously large for PERC. So everyone announces, of course, big plans for capacity expansions. So we will see what happens, and maybe also, let's say, in addition to Dr. Yu, I mean, in the end, heterojunction or TOPCon, I mean, if you have a full TOPCon cell, and I mentioned it in my talk that in principle, of course, in the moment, the front side is limiting. So, of course, in the end, you will target also to have a TOPCon junction also, or a TOPCon layer structure at the front side. And then, of course, in the end, in principle, the device structure of an heterojunction or an TOPCon is not that much different. Yeah, so you have in the end a relatively similar device structure. You are just coming from the equipment which is used, and that I think was mentioned at the beginning. You are coming from the existing equipment base of PERC towards TOPCon, whether you need, let's say, really new equipment for the heterojunction case. So in the end, of course, it's an investment decision, and it depends on where you are starting from.
Okay, but you know, the reason for me asking the question is also that is it really as easy as it is shown on these flow diagrams to get into TOPCon? So that was also the fundamental of my question, because you know, for Jolywood, of course, they have been working on this from years, and you as a from coming from the research center, so for you it making such cells may not be possible, may not be difficult, but you know, how are you also seeing any other industry player, you know, that can easily can do that? So do you see that confidence, because you are also speaking to others? So what's the industry take on TOPCon?
Okay, I mean that question, of course, would be best if we would have now, let's say, some other guys here in the panel which actually did that at least on a pilot line level in the past, like RENA, etc. As far as we know, I mean, they also made some transition from existing lines towards TOPCon. So I mean, I think that would be best to address to them what, let's say, they're the main or the main difficulties and challenges were. I mean, a little bit like Holger showed in his presentation, and which makes that for them, of course, quite nice. You can between PERC and TOPCon, you have for many processes relatively similar challenges to address. You have it in a different order, yeah. So, but I mean, high-end PERC or or TOPCon will have, let's say, similar, for example, similar requirements for cleanliness, etc. So it's basically it's a different kind of order. So you have to learn, let's say, how the processes are interacting with each other. And the main point for TOPCon still remains, let's say, the metallization. And this is in the end, of course, always a question of demand, how fast then, of course, new solutions for paste, for example, or even for other than metallization approaches, how they can be developed. I mean, if there's a strong need, you then also see that there is a much faster development for these new technologies or for these new materials.
So then I have a question to you. So, you know, what is the status of the production plans you are aware from the other companies? So as a leader of the technology, probably it's nice that you own the leadership, but you know, to develop a nice ecosystem that can streamline the supply chain, process chain. So are you also seeing any other companies, or do you have any estimate for the TOPCon market, how it's going to grow? You were mute.
Okay. Pardon. What do you mean the
No.
supplier?
No, what I mean to say that, so right now, if someone talks about TOPCon, it's only Jolywood that comes onto the mind because you were the largest. But it's nice that you were the biggest. But do you also see that there is a need for others to join so that the supply and process chain gets more mature? And then actually, do you see any companies expanding in a big way? Something like, how much you expect the capacity installation for TOPCon by end of this year and next year? TOPCon as a total industry.
Okay, for the TOPCon solar cells, in the last 4 years, Jolywood needed to develop equipment, materials, and so on. So it's a very challenge. Just one company to develop TOPCon technology, and in future, we hope the equipment supplier and the material suppliers and other companies such as top 5 companies such as J Solar, Longi, Jinke, and so on. We hope more and more companies can together to develop TOPCon solar technology. And if so, I think in the next 2 years, TOPCon solar cells will be become a mainstream of the solar technology in the pure market.
Okay, so then what do you think will be the global capacity for TOPCon by end of this year and next year? Do you have any rough estimate?
In the next year, the capacity for Jolywood, the capacity may be at least 3 gigawatt, maybe 3 to 6, even more. And for the 2022, the capacity will be much more. And other company, I have learned that some top 5 company has also expanded the TOPCon capacity in the next year. And in the next year. So I think in the 2021, the total capacity of TOPCon maybe 5 or 10 gigawatt, maybe, and 2022 at least 10 gigawatt, at least, I think.
Okay. Jochen, do you have any say on that?
I mean, it's a bit glass bowl. I mean, I can recite you, let's say, beside your own research, I think 2 or 3 other figures also from the commonly known investigation units, where you see, let's say, the 10-15 gigawatt capacity for TOPCon in 2022, or I mean, if you choose another one, you see exactly the same for heterojunction. So the problem in the ITRPV, for example, is that it is mixed because there TOPCon has no own section. It's more or less in the same. It's in the same part like the PERC cells. So of course would be maybe a good idea, at least for that kind of study, which is updated each year, really also to separate maybe TOPCon from PERC to have maybe a better understanding of the market at that point. No, I mean, it's in a way a bit like looking in a glass bowl. So we also have there no other figures what will happen.
Okay. Holger, do you want to
Yes,
add
you're
anything?
right. Yes, you're right. Yeah, we just is our capacity, and next year I think we will. Now we have expand our capacity. Are looking new new fab, and buy equipment to expand our TOPCon capacity. Yeah, and in the next 2 years, I think yeah, maybe 20 or 30 gigawatt, even more.
Okay. Then I try to tell you what I see in the glass ball.
Okay.
No, I see promising things we did in sampling for top 5 manufacturers. Out of them, there are a few, and if they go at least with 2 gigawatts, in my opinion. And then we will have according what you said, same size of expansion for them as Jolywood in 2021. And if the things turn out to be successful, then we will easily reach the numbers Leo said. I fully agree with him. And it's not like, yeah, I cannot share, of course, in such a panel, but I'm confidential what I've seen that the technology will work.
Okay, coming to the manufacturing, so apart from what is well known, so of course, the well known thing is about the wraparound, and there is, of course, there is also a solution. But apart from this, are there any bottlenecks for TOPCon? That's kind of pulling it down. Do you see anything?
So maybe I answer again. As I mentioned in my talk, I think I don't want to talk about pull down, but I would talk about challenges they face. And this is all in alignment what said people want to increase bifaciality. They want to reduce the poly thickness. In the meanwhile, they also reduce costs, increase throughput of the deposition machines, while LCOE gets better. I think it's the normal evolutionary steps you can see. The challenge is improve bifaciality, reduce metallization costs, and but I do not really see something which was not done in a quite similar way in PERC over the last 6 years. So the steps has to be done, and it requires a significant volume in production to drive R&D resources of suppliers and material vendors to that, and then I think these things will overcome. It depends a little bit on the initial point, and I think the move of the large wafers postponed every introduction of new technologies in 2020, and this is something yeah, maybe was for the development roadmaps of new cell technologies a little bit surprising or influencing their decision to go large.
Jochen, do you want to comment?
Yeah, no, I mean, I think that was perfectly summarizing what more or less actually the challenges are. I also just can to emphasize, I think one of the, cost-wise, one of the major aspects really is the metallization, definitely. And let's say performance-wise, also then later on for the module is the bifaciality and the reduction of, let's say, the thickness of the poly layers. But that, of course, again is very much related again to the metallization. Yeah. So I mean, there are in the moment, of course, limitations induced by, let's say, the current state of development for metallization, which limit a little bit the freedom to operate for other things in the cell. And therefore, that's always something which has to be addressed in combination. And I think this is one of the major topics for the future. But I think that was, already clearly worked out also in the presentations today. So that this is the big topic.
So, as far as the OPEX, I think one of the major concern is silver on both sides, and there is plating, which has really an effective way to get it down. So why plating didn't work so far so well for this technology? Holger, would you like to say something?
You repeat, please.
Plating is, why so far the plating has not worked for TOPCon so far. So, I mean, why there was no big adaptation of plating, whereas it clearly gives a cost advantage. So, is it just because now the silver prices have gone up, so now people started seeing the benefit of plating, or the technology itself is not well matured for large scale commercial deployment?
I definitely, I think if silver price dropped down again in a level of $15 per ounce, the whole story of metallization will flat down again. I think this is there's been done great jobs from the paste manufacturer. We approached with multi-bus bar, wire bus bars, all that brought the roadmap of silver consumption down. Right now, the larger wafers seem to get enlarged that not only by area but also by there needs to be spent more metal, and oops, all of a sudden 50% the thing goes up. And for the future perspective, this is what I say, but I know we say this since long, and we worked a lot with Chinko on it. It's a preparation for when the moment comes. It could be anticipated, but I don't think so fully by multi-bus bars. But right now we're facing with the TOPCon and with the heterojunction extremely expensive silver materials, which are not at this stage. And at this early stage, we're seeing also, as I mentioned on the first crowded slide I presented, that people in heterojunction doing right now hectic, a little bit, let's say, multi-actively plating and introducing a lot of others masking processes, where I just say, okay, this will be a lot of additional costs. And I've seen companies in the past failing by running behind the copper, but for the copper they invest so much. And for the PERC approach and for the TOPCon approach, it's a kind of straightforward. You use the passivation layers as masks. The laser things are developed, and here the high throughput tools can be used. So even with a multi-bus bar approach, it is attractive to get rid of the rest of the silver. And I think if a lobbyist would do a work and you will say, okay, there should be no lead anymore at all in PV modules, the story can even fly. I know that there is activities and a lot of good pastes already without lead, but to my knowledge, most of them still use. And this is my statement on why it not impacted. And of course, all technologies have to bring very significant benefit as new technologies to its users or customers. And it's the same for RENA products. So if Jolywood can even be more competitive and expand even more, they also consider the plating, I'm sure. What do you think, Leo?
I think it's have for plating technology now it's not a technology problem. It's just environment problem. You know, in China, now the global cell production is basically in China, and China EIA standards denies electroplating, which is very difficult. I remember in the 2050, our R&D lab wanted to buy an equipment, plating equipment, but the EIA was not approved for a year. So if in a mass production, I think it's a huge problem. And in the other hand, now the multi-pass bar have the get the slower consumption drop greatly, and the slower cost is about 10% per year drop every year. So for plating, I think yeah, not a technology problem, just our in China our environment department forbid the plating.
Maybe I would like to answer that. We've done a lot of research and work on that with the local authorities. I think you can show an wastewater management so that there's zero wastewater. I can forward it to you so that you really gain back all the metals out. And I talk really about all the metals out. So it would be a zero wastewater approach, which is even in China at these days accepted for the semiconductor and for the printed circuit board shops. And I believe this can also be made, but I agree with you, what I've heard, that certain regions do not allow at all. This is a challenge. You need to show these concept, but yeah, we made significant progress in that, and I believe if there's a political willing, then at the moment the technical solution is there to have no wastewater. I really talk about zero wastewater, and even the cost of ownership we presented, or I presented, is including this facility installation. And as it is used, as I said before, in printed circuit board. And one thing I want to highlight, I was really seeing this development in a direction that no authorities in China accepted plating in PV from 2016, 17 starting very massive. On the other hand, I seeing all the heterojunction guys right now, they invest in plating lines. How could this be, Leo?
Okay. I hope you can share some materials. We study the plating process, and for the heterogeneous solar cells, in the last 2 years, they also want to develop a plating technology. But now, this year, now they have also used screen printing technology to do metallization. And yes, it's a huge challenge for China in our EIA department to allow our local company to use the plating. But if your technology no environment pollution, I think maybe we can apply to our government to allow you to use plating. But the cost is very. We need the cost is the most competitive with the screen printing technology. For the G1 wafers, the slower consumption just for the PERC just 70 microgram. Yeah. It's very low.
We anyhow are in contact with your team. I will forward all that information to you, and then we will have a bilateral discussion on that again. I'm really looking forward. Thank you.
Yeah, so I think I also support what just Leo said, because GS Solar was one of the company that was working on heterojunction plating, but they also apparently shifted to screen printing. So, and then in one of the previous conferences where I attended, one large company, I mean the top tier company representative said when they wanted to go for plating, government said, okay, we can provide a common platform for every company to do plating. So that means they have to send wafers to that particular place and then get it back. So I think this, I also heard this. So then I have one more question regarding the manufacturing. So Leo, can you comment about the capex for TOPCon line in a gigawatt scale? So what is now about, and where do you think it is going to be in coming years? Leo?
Okay. Now for TOPCon, the second generation TOPCon technology, the 1 gigawatt capex is about 300 million.
300万
Yeah. Yes.
3亿3000万
Yes. 300 million dollars.
不对，3亿300 million 是3个亿。
It's RMB, right?
你说多少钱？帮你写。
3000万美金。
30
Sorry.
30 million USD.
30 million. Yes, 30 million. About 30 million. Sorry, 30 million. Not sorry.
30 million USD.
30 million.
Okay.
It's about 10 or 12, 15% higher than PERC, and it's very most the same.
Okay. So then I have one final question. I think we are also reaching towards the end. So, how practical is to have a, TOPCon architecture also implemented onto the front side? So questions to you, Leo, and also Jochen.
Yeah, I mean, TOPCon for the front side. I mean, that's of course comes there. Let's say the challenges you have already for the rear side are even getting more pronounced. So for the front side, of course, you definitely have to make it very thin in order not to lose, let's say, the light already at the front. And this again comes then with the question of metallization. So that is, in the moment, in our case, still in, let's say, an active field of more or less still R&D. How to do these layers at the front in order to make them transparent, conductive, etc., and matchable to a certain metallization technology. Of course, preferably a little bit, I mean, to match it with the existing lines with screen printing. But if that does not fit, of course, what would be then, and maybe plating is again there, of course, an option, like we already mentioned now a couple of times. So it may be even also the only solution for that, because it might be too difficult then for the screen printing. So we will see.
Okay, so I think we are running out of time. So I would like to thank each and everyone for this wonderful participation. Michael, over to you.
Okay, thanks, Shravan. Thanks to everyone. That was a great panel. So my takeaway is, so we went into this day with the question, is TOPCon an easy PERC upgrade towards higher efficiencies. Honestly, I have to say I was in the recent month a little bit pessimistic about TOPCon, but hearing here so many actually positive news, actually I'm much more optimistic after this day, learning about the efficiency roadmap of Jolywood and the cost reduction potential, which we see on the research side and also on the equipment side. It was really interesting because we saw a lot of details. I found the discussion on plating also interesting. Working myself as a lobbyist, it is of course often then the question to convince policymakers about a different solution. Apparently, as Holger has shown, the industry has done its homework, so you can actually capture 100% of the waste. It's a full closed loop solution. If it shows these huge cost reduction, the industry will for sure lobby, and there will be ways actually to push such a technology through. Just a few words once again, thanks to the panelists, thanks to the attendees, and just also again to the sponsors, Jolywood and RENA for today, and also all the other supporters. We have one day left, so 3/4 of our conference are over. Tomorrow we will have our IBC day, and here the subtitle is always lead to the efficiency leading technology. And we've learned also that a lot of companies are trying to sort of morph their technology into IBC. So we will have 4 speakers tomorrow, one actually from research, showing also new ways and to actually produce IBC technology. We have, of course, the long-time market leader and pioneer in that field, SunPower. We have also, and I'm very happy to have him, Charlie Gay, one of the solar pioneers, who is now working with a startup, new startup in the US to commercialize IBC, but who was also from the beginning actually with SunPower when they started working on IBC. I can still remember when we wrote an article at that time. And to give an outlook actually beyond IBC, what could be even next, and what we discussed basically in all 3 days also so far. So because what's the bottom cell for tandem technology? And that's why we have Gianluca from TNO ECN to give an outlook on the next generation. So thanks for staying with us today. Thanks for, again, all our supporters, and we look forward to see you again tomorrow. Have a nice day, have a nice evening, and if you still have time and are bored and don't have too much, still not enough solar, please download our HJT report, and then you have maybe a nice lecture to go sleep. Thanks, and see you back tomorrow. Bye-bye.
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 Bye-bye.